Creep me out. I'm done with this. 54.
Let's go.
So 54, we did part A yesterday, and we came up with this final velocity when he hits the water, 0.0071 meters per second. Now we're going to do part B, and we are going to find the diver comes to a stop 2 meters below the surface. Find the net force exerted by the water.
Hold on.
So now we have a Y final of 2 meters. Now this is why I'm saying I have that Y final of 2 meters. Is I'm looking and I'm changing my starting point now. I'm changing the starting point to the surface of the water. And 2 meters below it's where we drop. So I have an initial position of 0 meters.
There we are.
So we have an initial velocity, which is 14.0071 meters per second. Mr. Hall, how'd you come up with that? Okay, this is where you have to understand where you are in the problem. I'm changing my reference points. So whatever I finished with velocity-wise when I touched the surface of the water is now my initial velocity that's going to carry me through the water. So we come to a stop, which means we have a final velocity, 0 meters per second. And in terms of acceleration, we don't know it. I know you're in the Y direction, but this is falling in water. So now water is pushing up on us. Water.
Be water.
Don't we like water, don't we?
Water what?
Oh God,
Yes.
we done had this discussion.
Yes and no.
No,
Depends on the state.
yes, because
The real
water,
question though.
Okay, in English,
Is a
no.
hot dog a
In
ham-
science,
or-
yes.
It's a hot
No,
dog. a taco,
no,
or
no.
a
No, in
sandwich.
English, yes. And in
Is
science,
water
yes.
magma?
What?
No.
Why would
Yes.
water be magma?
No, it is not.
Ask
Why?
Hank
You're
Green.
gonna look at your chemistry teacher.
Hank Green.
Yes, it is.
I don't care what Hank Green's gonna say. It's not magma. Magma is a molten rock underneath the Earth's surface.
But are icebergs rocks?
No, it's ice.
Rocks. According to Hank.
All right. So we gotta find the force. So in this, we're looking at force is equal to mass
I
times
can put water inside
acceleration.
the earth.
We have the mass of 65 kilograms. I guess I should add that.
What was acceleration?
We have to find it.
okay.
Do you do tutoring for this class?
Yeah, I do.
Yeah, sure.
Yes, sure.
You do after school tutoring, we can get pizza.
I don't care. Listen, if y'all want to come, we can just pile in at my kitchen table for all I care.
Okay. Well, I'm gonna make
Sure, that does.
Well, thank you.
For the video,
Let's do
we
it.
are taking
Mary, you
COVID
make it sound
precautions.
Ripon Alston, come to the office.
We are taking.
We will each be tested and wearing our masks.
I will have marks on my floor 6 feet apart.
Exactly. He will sanitize his whole house.
Yeah.
There will be a vacuum seal around each space.
We'll be in our own like little
So, find the find the force exerted. I actually love this class. I really do. Y'all make my day.
Aww.
That's sweet.
He says it's only because it's 260.
Yeah.
So find the net force exerted by the water. So we got to find acceleration.
9.81.
No.
What?
Because remember, this is where we're hitting water. We're no longer falling under
Your
gravity.
weight.
There's a net force pushing up on us now, and that's what we're trying to find. So we have to look and find the acceleration. Since it gave us the change in displacement, we got to use that to find the acceleration. In order for us to do that, we have to use final velocity squared equals initial velocity squared plus 2 times acceleration times y final minus y initial.
Again?
You don't know F though.
But
What do you mean?
Why'd you put F?
That's fine.
on there?
That's your final position.
no,
Above it.
she
F
meant
equals
force.
A.
You
Because we
already-
gotta find acceleration.
Okay, but you already found your initial velocity, or
But you don't know the force, so how would you do both?
oh,
I don't
wait.
need force
I know
for
what
this
you're
one. I'm
doing.
gonna find acceleration out of this one to plug in for force there.
Never mind.
That was me just explaining my thought process. Why am I having to pull acceleration now? It's because I need it right here.
Okay.
Okay.
So now in this, we gotta move everything around.
Because you already know everything for that, so you can pull acceleration out of it.
Yeah. I'm not gonna jump. I ain't gonna do it to you. Y'all freak out on me. So now we'll get 2 times acceleration is final velocity squared minus initial velocity squared
Well, how do you know
divided by y final minus y initial.
Well, sneak
You know,
attack
I
on
leave
them or
you
something.
on. I leave you guys on sometimes, so it doesn't matter.
Why'd you do that?
Because I'm trying to get acceleration by itself.
Hold on, how did you get the 2A over?
I just moved it over. I like whatever I'm solving for to be on the left.
Okay. But it can stay on the right if you want.
Yeah, you can leave it on the right
But
if you
can
want
I
to.
ask you
just don't like
something? Can we
solving.
solve it now and divide by 2?
You can, but I hate doing that.
Why would
Because
you,
I'm science minded and not math minded. Y'all are math minded.
Why would you do this?
Because just
It's just not right.
I feel like it's
See, that's what you think, but then, like in all the science classes that I've been in, I always like to get what I want to solve for by itself completely. Then I solve. Like, I'm literally just going to do this. Acceleration
I thought
equals
y'all just
velocity final squared minus initial velocity squared divided by 2 times y final minus y initial.
okay.
Because I'm multiplying both sides by 1/2
And then you flip.
Oh,
Then you
hold
to
on.
get rid of the 2.
Okay. Yeah.
Hold on.
So now acceleration will be equal to, and I'm going to start filling in my numbers. So this final velocity is
Hold on
0.
1 second.
Why did you times it
I'm
by
waiting.
2?
One
Why
second,
did you times
please.
it by 2 on the bottom?
To get rid of the 2 on the left side.
But what, you divide it? Since you said it wrong.
I'm multiplied by 1/2. You still got rid of it.
Squared.
It's the same thing. You can divide it by 2, but it's the same thing as multiplying by 1/2.
Oh, God.
Your 2 is at the bottom.
You divide it by 2.
I did.
Okay.
Then why is it at the bottom?
Because that's where it goes when you divide by. So we have negative
So it would just be
14.0071 meters per second. This is going to be squared. This is going to be divided by 2 times y final.
Hold on, we can't see it.
You're going way too fast.
Listen, I'm having a T and it's not even energized.
It's 2 squared.
2 meters
No.
minus
Zero.
0 meters.
Is that squared outside?
gonna be a big
Okay.
number.
Yes.
It's not a part of the unit.
Okay, it's not
Really
the
big
unit. Because I was getting ready to question on that.
Getting 3,000.
Boogie. Yeah.
Oh,
What did you get?
Wait, can I get away?
What did you get?
Oh, no.
Oh my god.
I got,
Uh,
right here, I got 49.0497.
I did not.
That's
But
I got 3.5.
the force, I got 3,188.2305 newtons.
How did I get that wrong?
Sounds about right.
Yes, sir.
so now if I'm forward,
Aha, I got it.
It's in there?
65.
I might vote all over your company.
Ticks me off. Every time we give them out for the PSAT or the SATs or anything, somebody that will sit there and come back to me, somebody's took a pencil on it. And it's like, I really want to know who did it.
Now I know.
You could turn them into the SAT for that.
Yeah, their school won't be scored.
I'm the idiot that would put Miss my calculator.
So this will be in newtons.
Wait,
Correct.
where'd you get?
65 kilograms came from the problem.
But will it be negative? Or are we going?
Newtons. Okay, so the question here is should it be negative or should it be positive?
I feel like it should be positive because of positive direction. Like, it's only negative.
What did we do with gravity when we used it before?
We made it positive.
We made it positive, so in this case, this number should be negative. Because
Oh,
it's
we
going
made
up.
gravity positive?
Wait,
Now, in this case, on the technicality, when we went to B, we switched everything around, so you still could
This is
change
the
your
force of
reference.
the
No,
water.
we made,
Yes.
we made,
Okay.
never mind.
Not on this.
We
This
did make,
Gravity down.
we did make down positive.
Yeah.
But on part B, whenever we came up here and I did all this, when I reset this, I changed everything. I could have changed my directions of everything.
So is water the natural force?
No.
oh,
You're thinking normal force, and it still isn't that because it would set. It's when it's sitting on a surface. That's the key for normal force.
See, that's what confuses me.
That's what
whether-
that's confusing me
whether
too because
negative.
Okay,
water
the key
is
is
a
it.
surface.
The key is it with normal force is it's sitting on a surface.
Yeah.
It has to sit on a surface. So, like in the next chapter, I'm gonna give you problems that I have signs hanging from a
So
wall
there's a
or hanging
break
from a
in
ceiling. It's not sitting on a surface, so it doesn't have normal force.
Oh.
Has to be sitting on a surface. Now, technicality in here, there'll be boiling force, but you don't get to
Voice.
that. Yeah, I think it's maybe like chapter 12 in here. What's up?
so can that 3,000, can that be a negative or a positive, or does that have
Yes,
to
it
be?
depends on how you break it down.
Okay,
How you want.
you know where I'm still lost? So,
But you have to prove that gravity was your negative.
wait a
Well-
minute.
How do I,
Whenever I look at your problem, I can figure out what you've done.
Okay, so if I do all that and it's still positive,
It's definitely because you just,
Okay, so perfect example here is my initial velocity.
mm-hmm,
My initial
that
velocity
one
has
would
me
be
going
negative.
down.
mm-hmm,
I have it being positive.
mm-hmm.
So it still has to be, this is positive and my y final's positive. Down's positive. This force is going up. Since
your
this force
y
goes
final
up, it
is
has to be
not
negative.
Okay, so if you
I
would have
gotcha.
made your initial velocity negative, then the answer would have been
And
positive.
your y final. If they would
Y
have
final and my,
But on a test, if they would have been
initial
positive, then
velocity
that
would
would
have
have
been
been
negative, and it should
positive.
be
It
positive.
would have been wrong.
yes.
Is that why? I feel like that's why I got that one question wrong. Definitely
Depends which one you're talking about. The one you got wrong because you said there wasn't something there, that there had to be something there. that
Okay,
probably makes no
is.
sense.
Yeah, that's because I thought you were talking about the initial velocity, but it was the final velocity.
Well, let's talk about the initial velocity.
Really?
Yeah. For the object to move, there had to be
Yeah.
a velocity. You put 0.
don't feel bad, Maddie, I did the same thing.
All right, questions here.
Then how's the initial velocity 14.0?
Because it switched. Like that was the final velocity we saw for before whenever we touched the water.
But you were stuck. Solve question. Didn't we ask him last year, like, what would be easier, like hitting the ground, a tree, or water? And you said, well, it depends on the force, and we just wondered.
I don't know what you're talking about.
Like what would hurt less?
Yeah, what would hurt less?
Depends on the force. Like how
It
you're
depends on how hard you
impacted,
hit
the
it.
surface area, everything.
What if they was all the same?
So,
Like, would you rather have an
At
elephant
some-
step
okay,
on
can
your
I ask you
foot,
this?
or
At
would
some
you rather
point-
have a 120-pound woman with a pointed high heel step on your foot with just the point of the high heel?
what was the
It's the
first?
same
They
question.
both hurt, but
Would you want an elephant to step on your foot, Or would you want to take, let's say Christy for example, and put her in pointed, a small point in the back, high heel, and have her stand on your foot with just a point?
I mean, I'd take Christy in today.
Oh.
Christy's like 100 pounds.
Exactly, that you want the elephant.
Yeah, because
When you do the
also-
math, she will exert more force because of smaller surface area. All of her weight has to go to one point. When you look at the foot of an elephant, all of it's spread out.
So you're saying,
So the
Either way, your foot's gonna get broken.
So the high heel would hurt more than the elephant.
Yes.
I didn't know that. Wow.
That's exactly the same question you're asking. How you're going to hit. There's so much about impact.
Wait,
that's why a
figured
poke can hurt more than slap.
Yeah. Wow.
Oh my gosh. That's crazy. I never.
Wow.
All right,
Okay.
61.
I'm questioning everything going on in life right now.
Rain, a 2.5 milligram raindrop falls. So we have a max
Drop. Drop.
2.5 milligram.
The video gets copyrighted.
Falls to the ground. As it's falling, what magnitude of force does it exert on Earth?
Are we establishing gravity is negative?
Wait,
You're
no,
gonna
no.
open the
Resay
video
that.
or back and it just said
Resay it.
First thing,
Sorry.
It's just
Excuse me.
close.
Don't say a word. I seen it.
Okay, this is what we're looking at. We have a 2.45 milligram raindrop falls to the ground. As it's falling, what magnitude of force does it exert on Earth?
We should do
So we have
that.
to convert that to kilograms?
let's do it ourselves.
I got, like, everybody's yelling stuff at the same time. I cannot. Logan
And they're,
first.
oh.
We should do this ourselves. Just to try it.
Yeah. Okay.
Oh
Please.
God.
Hey Siri, start me a timer for 2 minutes.
Wait, can we get, I need my book.
How much is your
timer is set for 2 minutes.
Negative 30.
Where's that?
Negative.
I don't even have them.
Why would you negative 3 for?
Were you here when I got
You have to change it to kilogram.
what?
Milla to
Oops.
kilo is a positive 6.
What's the little K?
Does it have to be in kilograms or can it be in grams?
No, I have to be in kilo to get newtons. Can I have the other? Do we have to find acceleration too? I need a book.
Steve on the bottom of your desk.
Mm.
Not somebody stole yours and then it's probably sitting on the cart back there.
Hey, wasn't that not an equation that we did?
Mm-hmm.
Wow. It's amazing how that works.
Oh, wait.
I know that. But they gotta be something else you do because that doesn't.
Waiting on my timer to run out. I'm bored.
Yeah.
I can't hold up on my phone. I can't remember how to
150?
move
Ow.
that.
I got hurt.
Just don't post it. Kiss his feet.
Is the thing we use for this Newton?
Oh,
How you know? Hey Siri, start a timer for 2 minutes.
Okay, 2 minutes and counting.
I'm gonna start doing it every time y'all answer something correctly. You wrong.
I swear.
We have stuff on this so much stuff.
Thanks.
Just see it slowly going. What? I don't know how to do this.
You do, you're just waiting for it.
God. I swear.
Oh no. I just did this whole thing wrong. Or no, wait, did I? Yeah, I did.
About that.
You're having too much fun.
Alright, let's solve this thing.
God.
So, somebody said it, you're right. We gotta get this into kilograms so that we can have newtons. So 2.45 times 10, something another. Gotta figure out what that something another is. By the way, I did send y'all that answer key to that sheet I gave you guys. So,
Yeah, I'll have to look
feel
at
free to watch that and
it. Yeah.
get that down. So we got milli first, so milli is -3 minus kilo, which is 3, which gives me -6. So 2.45 times 10 to the -6 kilogram. So that's my actual mass I'm looking at. Now in this, I'm trying to find the mass exerted by the raindrop. So the raindrop falls, hits the earth, bada boom, bada bing. What is force? Weight. So it's mass times gravity, which would be equal to 2.45 times 10 to the -6 kilograms, and times that by gravity. Now, we do have to answer the question Logan was asking at first. Are we going to set gravity as negative? We're going to set it as positive, and it's up to you whatever you want to do here. It's pretty much going to determine what you want. I would be positive because this is literally it in this problem, so all I'm going to deal with is positive numbers, but if you want to do negative, you can. It just means your force will be negative. In this case, 9.81 meters per second squared. Give me a second to punch this in my calculator.
I don't remember how to do
Okay.
it. How do
Well,
you do times 10?
You would do 2.45
Second E.
second, the comma right above the 7. You get the little e. And then you get -6, which technically I should have put that in parentheses.
okay, so.
So I'm going to hit enter so that it don't jack me up and it reads that I want to take that whole number times 9.81 instead of it's thinking that I want that exponent to be multiplied by 9.81. And I get 2.4036 times 10 to the -5. 2.4036 times 10 to the
So 55.
-5.
That's what I thought. It should be fine.
I got -5. Yeah,
What is it?
I got -5.
4 doesn't round up to 6.
Yeah, it should be.
Yes.
4.055.
He would have been all over that if I was us. He'd be like, no.
Now, actually, I would look and I would just say like, yeah, they rounded wrong. I'm not grading on rounding. I'm grading them on physics.
That's all about
Oh, this is the guy.
Oh, man.
What a man.
That's good. That's a good lecture.
That was a good swig.
Right.
Nice
Well,
swig.
Questions on 61.
That's the type of question questions we'll have on the quiz, I'm feeling confident.
Have your confidence.
I'm better with the Mr. Hall question.
Yeah.
If you drop a teardrop on the earth,
A teardrop.
He says calculate the force of your teardrop on this
Honestly though,
He said if you're hovering
Your
over-
eyeball is 3 meters above this piece of paper that you're reading on. You have already cried 7 tears. They have fell and hit this physics quiz.
what is the grade?
What is the weight of the sun?
What is the grade you were
That's
on?
honestly what my brain thinks when I read these. It's exactly what you said.
Yeah, pretty much.
Fantastic. All right. Do you all want to give number 62 a shot?
Sure.
Let's do it
Yes,
to
sir.
it.
I think we'll need more than 3 minutes.
I'm actually going to give you the rest of the time today for you to give 62 a shot.
Oh, this one must be a long one, man. I know.
Page 115.
I haven't even got a book.
62 reads, male lions and human sprinters can both accelerate at about 10 meters per second squared. If a typical lion weighs 170 kilograms and a typical sprinter weighs 75 kilograms, what is the difference in the force exerted by the ground during a race between these two species? Both the forward and normal forces should be calculated.